So for chapter 5, it's called Radical Expressions and Equations. We did a little bit of radicals in grade 10, but we're doing more now. Ironically, though, back in chapter 4, you were working with radicals when you were reducing your square roots anyway, so you have a little bit of a background of that. They almost probably should have done chapter 5 before they did chapter 4. But anyways, so the very first one is 5.1, and we're working with radicals. Okay, and you guys don't have this page in your textbook, or sorry, in your notes, but this is straight out of your textbook, and it's talking about like radicals. So I'm not sure if you could read this at the back, so I'll just write them. Pairs of like radicals would be things like 5 square root 7 and negative square root 7. Okay, the reason why they're like radicals is we kind of treat them like terms. Like terms would have been like 10x and then negative 5x. They have the same variable piece, they just have different coefficients, but those are considered like terms. These ones, you can almost think of this as being your x's here. So they have those similar radicals, or like the similar x's had, and they just have different coefficients in front. Okay? And then unlike pair would be something like 2 square root 5 and 2 square root 3. These are different items. This is 2 of the square root 5 items, and this is 2 of the square root 3 items, so you can't put them together because it's like saying 2 x's and 2 y's. You couldn't combine them together, okay, with adding and subtracting. All right? Restrictions on variables is another thing they talk about. If your radical has an index of an even number. Now, if you don't remember those terms, what happens is this is where your radicand goes. So if you want to put this on your formula sheet, you can, radicand. Your index is that little tiny number that fits kind of above your little square root, like little piece. And the entire thing is considered a radical. Okay, so you have a radical, a radicand, and an index. If your index is even, like a square root, which we don't even see the index on a square root. They don't put a number there because it's the most common one, but it does have a 2 there because it's the opposite operation of squaring, right? So, and squaring has a 2 as its exponent. So, a square root does have a hidden index there of 2. Square root, 4th root, 6th root, any even root, you can only root you can only root positive numbers. Okay, so if your index is a 2 because of square root, you could square root 8, you could square root 10, you could square root decimals as long as they're positive, so the square root of 2.5, it's not pretty, but you can do it. You just can't square root or 4th root or 6th root or any even root of a negative number. If you try it, you're getting an error on your calculator. Okay? However, if your index is odd, so if it's a 3, a 5, a 7, you can cube root, 5th root, 7th root, you can odd root any number, positive, negative, it doesn't matter. Okay? So that's where we get into restrictions on variables. If there's a variable under your square root, so if you have a variable that's underneath here, let's say it's x, okay? What I tell you to do is I tell you to check. I always check positives, negatives, and zeros. If there's no adding and subtracting, those are the things I check. Positive, negative, and 0. Can x be positive in this case? Can you square root a positive number? Yes. Can x be 0 in this case? Can you square root 0? Yes, you just get 0, but that's okay. It's not an error. Can x be negative? No. So when you talk about that, I talk about positive, 0, negative. This is good, this is good, this isn't. So how do you describe this in set notation? It would be x would have to be greater than or equal to 0, and then x is an element of reals. So if they ask you for restrictions, that's the kind of stuff we're looking for. And again, I'm going to stress, I look at positive, negatives, and zeros if there's no adding and subtracting under there. So another good example would be something like this. Okay? I look at this. And I got 2 variables here. So I'm going to have to check plus, minus, and 0 for my x's and for my y's. Okay? You don't have to write this down. We will practice this, but if you wanted to, you can. So let's take a look at my x's. Can my x be positive? Yeah, because I can square a positive. I still get a positive, and I can square root that. So this one's good. Can my x be negative in this case? It can, because you square that negative first, reversed, it would no longer be a negative, it'd be positive, and then you could square root it. So in this case, because of the squared, all of these are good with the x's. What about the y's? Which ones are not good for the y's? The negative one, good, because if you take a negative and you cube it, you still get back out a negative, and then you couldn't square root that. So this one would be one that doesn't work, but the rest of these would work. So how would you describe your restrictions in this case? X is an element of reals, and then y would be greater than or equal to 0, and y is an element of reals. So you can come up with your restrictions quite easily. Okay, so check your positive, negative, and zeros if there's no adding or subtracting in there. If there's only multiplying, it's okay. Be careful if there's dividing. Even if this is a number 9. Positive, negative, 0. What is not allowed for x? 0 is also not allowed in this case because you can't divide by 0. Okay? A 0 on the top is okay. A 0 on the bottom is a no-no. You cannot do that. I got that from Pinterest. Okay. So write that down. That's really important. Very important. Okay. If it does have adding and subtracting, what you do is you treat it like it's an expression. Okay, so the one that they have here is they had, underneath the square root, they had 4 minus x. So if you have adding and subtracting underneath a square root as your radicand, to check your restrictions, you just know this entire thing must be greater than or equal to 0 if it's a square root, right? So that's what you do. You have your expression, 4 minus x is greater than or equal to 0, and you try to solve for x. Okay, now, when you read inequalities, which are greater than or less than symbols, you need to read them from left to right. Okay? Because this is a greater than symbol. So your x needs to be on the left so that you can say x is greater than blah, 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 blah. If you move it over to the right, does everybody see how you can move it by adding it over there? Right? And then it'd be positive. But then you have to read it from the left over, and when you read it that way, you have to read it as x is less than, you're reading it that way, which is super confusing. Okay? So I always keep my variables on my left-hand side, and I'll show you how to get rid of the negatives in a second. First, how do you get rid of the 4? You subtract it because it is a plus 4, so you minus your 4 over. You have a negative x is greater than or equal to negative 4. How do you get rid of the negative x? How do you get rid of the negative piece? Divide by a negative 1 or times by a negative 1. I usually divide. Okay, so you get x here, you get 4 over here. Does anybody remember what it does with your inequality? Good, it flips the switch. So this will have to be a less than. Which makes sense, because remember I said if you would have added it over to the other side, even though this is a greater than symbol, you had to read it from the left over, from the right over, you'd have to read it as a less than. Okay, so that's kind of like a little review of things you need